All right, so I want to get back to what we're talking about with reference numbers, reference angles, that sort of thing from Friday. Let's find the reference number for each value of t. Okay, so what we were talking about on Friday at the end of class is I gave you those formulas for things existing in the first, second, third, fourth quadrant. To be frank with you, I don't know those. I don't. It takes me a minute to generate. I don't memorize them. I guess is what I'm trying to say. And for the mere fact that I don't usually use them. Okay, and I don't use I guess I don't use them directly. I probably am using an aspect of them when I answer the question that I'll ask myself on each one of these. But I don't think that is going to benefit you in memorizing those. Okay. So I'll walk you through kind of the process that I think is most beneficial in finding what a reference number is for these values of t, these distances. Okay. The reference number is going to be analogous to what we talked about in Chapter 5 about the reference angle. Okay? And we'll try to have that discussion here as we move on. Blaze.
Do we have a quiz this week over?
We do. Not tomorrow. Okay. All right, so find the reference number for each value of t. So this is the idea. So t, remember, because we're in a unit circle, we can view this a couple different ways. Unit circle, t, which is an arc length, which is found by S equaling R times theta. But in our case, because R is 1, we get T is the same thing as S, the same thing as theta. Does that make sense to everybody? And we talked about that previously. So when they say T as 5 pi over 6, they could be talking about that, or they could be talking about that angle there of theta. Does that make sense?
How do you know it's that big?
Okay, well, that's what I'm going to get to. So here's the idea. We know this is 0 radians, right? Yeah. We know that all the way around, again, will get me to 2 pi, right? Halfway would be pi, right? Now the question is, how do I know where 5 pi over 6 stops? Is that the second quadrant, third quadrant, fourth quadrant? How do we know? This is how I do it, okay? Not saying this is the best route, okay, but it's, I think, very efficient. I always look at that denominator, okay? And I'm going to write everything in terms of that denominator. And the two things that are most important for us to determine reference numbers are the x-axis, the values on the x-axis. So I'm going to rewrite this as 6 pi over 6. Is that still pi? But it's in terms of that denominator, right? And we'll write this as 12 pi over 6. Okay? Now, there may be situations that exist that you might need that one, like 3 pi over 6. Or you might need the other one down there at the bottom, which would be 9 pi over 6 in this case. But I rewrite all my quadrantal angles in terms of sixes, and specifically pi and 2 pi. Okay? Because now, all I have to do is compare, in my t value, 5 pi over 6. All I have to do is compare the 5 with the 6 or with the 12. Does that make sense? Okay. So is it before 6 or is it after 6? It's before. So I know that this t value that we're going to trace out here, it's terrible, is going to stop before we get to 6 pi over 6. So that's my t value of 5 pi over 6. Now the reference number that we're looking for is just like the reference angle that we were finding in Chapter 5. We wanted, in Chapter 5, it was how much more of an angle do I need to trace out to get my terminal ray to become the x-axis. Here, I'm thinking about it as this t value, this distance, how much further do I need to travel to get that point right there to become that point? Pi over 6. So t bar is pi over 6. So my reference number is pi over 6. Is that okay? Grab your unit circle sheet that I gave you, or that we worked on last week. So remember, a reference is something to look at to tell you something about something else, right? You need one? It's not going to be, it's not filled out, so you'll have to grab somebody and help fill it out. So a reference number, or thinking about, reference books in the library, are things that I look at to tell me about something else, right? Okay? So if I go to encyclopedia, that's something to look at to tell me something about whatever I'm looking up. Okay? This is my reference. T bar is my reference. I'm going to look at pi over 6. Look at pi over 6 on your unit circle. What's the ordered pair? For pi over 6. Radical 3 over 2 comma 1/2, yes? Okay? That is my reference number. That tells me everything I need to know about the ordered pair for 5 pi over 6. What's the ordered pair for 5 pi over 6? Negative root of 3 over 2 comma 1/2, right? Is it the same ordered pair, regardless of pluses and minuses? Yes. And we know that we can change the pluses and minuses because this one's in the second quadrant. T is in the second quadrant. So pi over 6 is the reference for 5 pi over 6. Okay? So what's that telling me eventually? It tells me with all these angles that we're going to do, all the questions that we do throughout the entire course, all you've got to know is that first quadrant. Okay? And if you know that first quadrant, you can reference the other angles off of that. Okay? Huh? Okay. So now we're at 7 pi over 4. Okay, so 7 pi over 4. Were you awake Friday to put together? Do you even have it?
Got it.
Okay. Is it completed?
Yeah.
All right. So 7 pi over 4. So there's 0. There's pi. Come back to 2 pi, right? Now, because I'm in force, I'm going to rewrite this as 4 pi over 4, and this is 8 pi over 4. And I think in this one it makes sense to rewrite this one as 6 pi over 4. Okay, they are still 3 pi over 2 and pi and 0 and 2 pi, right? Just unreduced. Because now, if my t value is 7 pi over 4, I know that I can travel beyond 6 pi over 4, but stop before I get to 8 pi over 4, right? So we'll stop maybe right there. Okay? So now the question, that's t. The black one is t. T bar, how far do you need to go to get back to the x-axis? If I stopped at 7, if that's 7 pi over 4, that black arc, then you need to go pi over 4. Okay? Now, if you go back up to what we talked about on Friday, it said if we were in quadrant 4, if you knew you terminated quadrant 4, then your t bar is found by taking 2 pi minus t. I go 2 pi minus t, so 8 pi over 4 minus 7 pi over 4, so it's giving me my pi over 4. Okay? So when we draw this picture and we think about how much further do I need to get to the x-axis, it is ultimately doing that subtraction that was provided in those formulas from Friday. My thought on formulas, though, because this course is ultimately eventually inundated with formulas. If I can remove 4 formulas from my memory, that's going to benefit me, I think. So I want to focus on this. I want to use this process, this procedure, and I think it's going to help out a lot. Do you like dealing with negative distances, negative angles? Okay, so let's not deal with this as being a negative. Let's make it a positive. So what do I need to do if it's a negative 2 pi over 3? What do I need to do to that number to make it positive? Okay, add 2 pi to it, which is 6 pi over 3. And that gives me 4 pi over 3, right? So I'm going to rewrite this as 0, 3 pi over 3, and then 6 pi over 3, right? Okay. Now, there's still a question, there's still debate. Obviously, I know I'm going to be in the third or fourth quadrant, right? This point here is halfway between 3 pi over 3 and 6 pi over 3, right? Yeah. So halfway between 3 and 6 is 4.5, right? Okay, so when I draw my t value, what quadrant am I stopping in? I'm going to say 3, yeah, because it's 4 pi over 3, right? So it's the 4.5 pi over 3, so I got to stop there. Okay? Now when I do that, the question is, I always talk about going to the x-axis or back to the x-axis, okay? And it's always the shortest distance. So, in the ones that we've done so far, we've continued to move in the direction kind of counterclockwise to get to the x-axis. But here, the shortest distance is actually to work backwards. Does that make sense? If I stopped at 4 pi over 3, how far do I need to go backwards to get to pi or 3 pi over 3? Pi over 3. So t bar in this case is pi over 3. Okay? Look at your unit circle. Look at the ordered pair for 4 pi over 3. Okay? Now look at the ordered pair for pi over 3. Same structure. Still 1/2 radical 3 over 2, right? Okay? But they're negative. Does that make sense, everybody? Think about this, and there's some symmetry. So these guys back here saying they flip some things. If I look at this point here, so that's where like maybe pi over 3 is. There's 4 pi over 3. Those purple dots. Would you agree that if I reflect across the y-axis and then reflect across the x-axis, those 2 points land on each other? You guys remember what kind of functions do that if they have reflections or symmetry across the x-axis and the y-axis at the same time? Or a reflection across the origin? Symmetry across the origin? O? No. No. When I think of this word, I think of you. Odd. They're odd functions. Okay? So we have, you're odd.
I just want you to know, I didn't say anything, but you said going this way, counterclockwise, but it's definitely clockwise.
Going which way?
You said we've been going counterclockwise.
We have been. We've gone that direction each time. That's counterclockwise. I know you can't tell time on an analog clock,
okay,
but
yeah, you're right. All right, I can correct you.
So thank you for not saying anything when I said the right thing. Appreciate that. Again.
I don't know why, but I thought that was clockwise.
To be honest with you, I gotta pause and think before I say counterclockwise and clockwise. It's just weird. I don't know. But does that make sense, everybody?
Yes, Professor.
Okay. So the next one's like part E on question 3 on your test. Okay. The pi is already in there. The pi has already been multiplied through by something to give me 5.8. Okay. So now, when I rewrite my quadrantal angles of 0, pi over 2, pi, and 3 pi over 2, I'm going to write them in decimal form. Because that just makes 5.8 much easier to compare to, right? Okay, it's hard to see. Does 5.8, is that less than 3 pi over 2 or more than 3 pi over 2? If I write 3 pi over 2 as 4.71, that's an easy comparison. It's more. So when I draw out t, here, I'll go beyond 4.71, and we'll stop about right there. Okay? Now the question is, how far do I need to go to get to 2 pi? Or to 6.28, right? All right, so how would I find that distance? Good. 6.28 minus 5.8. Now, I would probably prefer to write it that way, and that's what WebAssign is going to ask you, because it'll have no directions on how you round. So then the implication there is that you do not round. That may be, like I said, the only instance in which I maybe use those formulas from Friday that I gave you. Okay, about what quadrant you're ending in. Okay, but I don't think you need to memorize that, because I think you guys know all the way would be 2 pi, but I stopped short, so how do I find that distance that I stopped short? 2 pi minus 5.8. Oh, well, you're going to need to know those. Oh, you will. Those are, well, see, so here's my argument. You shouldn't memorize the unit circle. You should know the relations that allow you to build it.
Okay, you want me to memorize it?
No, I want you to know that this angle right here, which is 30 degrees, is because of that 30, 60, 90 triangle. And because that's a 1, and because you know 30, 60, 90 triangle, that's 2n, this is n root 3, you should know that that triangle right there is going to produce that ordered pair, which is radical 3 over 2, comma 1/2.
All right.
And then the next one is a 45, 45, 90. And you should know because R is 1, that's root 2 over 2, root 2 over 2. And then because of reflections, 60 degrees is going to give me that point there, just flip-flopped. And that's how I know the first quadrant. But I didn't memorize anything. I just knew my special right triangles. Because I know maybe the only thing I have to memorize here is the Pythagorean theorem, a squared plus b squared equals c squared. That would eventually generate all of this. Huh? Well, I don't know that I've memorized it.
I don't have it memorized.
Okay, so that's the thing. I'm not getting those things from, because the memorization is a low level skill. Okay, I want us to know why. I want us to be able to create, to synthesize, because that's a high level skill. When you work with these things long enough, it no longer becomes memory, right? It becomes knowledge. Does that make sense? Okay. It's just things that you know. Okay. There are things that you are never going to forget in your entire life, right? Until you get Alzheimer's, dementia, whatever. Okay. But that's a disease that your brain deteriorates, correct? It's not that you forgot, it's that your brain is disappearing. Okay. So what I want you to know is, eventually, when working with this stuff, you haven't memorized it, you've learned it, okay? And I think there's a difference between those words, learning and memorizing, okay? So here's why we're doing this. Here's why we're doing this initial reference number, okay? Because my goal is to be able to ask you, what is the point determined by this, okay? So the point that is determined by, I remember, we said 5 pi over 6 stopped right there, right? So what was the t-bar value? What was that remaining distance we had to travel? Pi over 6, right? So because t-bar was pi over 6, you're now going to reference into the first quadrant what that ordered pair of pi over 6 was. Root 3 over 2, comma 1/2, right? Yeah. Now that ordered pair becomes the ordered pair for 5 pi over 6. But 5 pi over 6 is in what quadrant? Second. And every point in the second quadrant has an x value that's negative. So now that terminal point is negative root 3 over 2, comma 1/2, right? Now, why are we doing this? Because eventually my question is, what is the cosine of 5 pi over 6? Well, cosine, remember, and let me just go down to this picture here real quick. If I'm working in this circle here, where that point right there is an x comma y. Okay, what is the radius of this circle? 1. Okay, that means that distance is x, that distance is y, right? And whether I'm looking at this t value there, or I'm looking at that theta right there, if I ask you what is the sine of t, or what is the sine of theta, you would tell me what? You say y over 1, wouldn't you?
Just about theta.
Okay. But wouldn't you just say y?
Yeah.
Okay, so what if t was 5 pi over 6? We still have this radius of 1. We now have that distance as negative root 3 over 2. This distance is 1/2, right? There's theta that I'm worried about, or there's the t value that I'm worried about. Okay? the cosine of 5 pi over 6 or the sine of 5 pi over 6, because we're in a unit circle, is just the y value for sine, just the x value for cosine. Does that kind of make sense?
Yeah.
So ultimately, the goal, and we'll pick up with this on Wednesday, will be come down here and say, when I'm looking at the unit circle, those 6 trig ratios are true. The sine of your t distance, or your, if you want to still keep calling it theta, that's fine, is just the y value of the terminal point. Instead of doing opposite over hypotenuse, we can just say it's opposite, because the hypotenuse is an understood one, right? So the sine value is just the y value of that ordered pair. The cosine is just the x value of that ordered pair. And the tangent is opposite over adjacent, but the opposite was y and the adjacent was x. So if I want to find the tangent from the unit circle, I just take the ordered pairs and I divide the y by the x. And that gives me the tangent for each of those t values or thetas. And then the secant, cosecant, cotangent are the reciprocals. We'll pick up with that on Wednesday. I'm going to keep the current homework assignment 6.1 due on Wednesday. Okay? I think that needs to be something that we focus on and get done and expose ourselves to before we can really get into 6.2. We need to develop that 6.1 skill. Okay? So if I push that back further, I don't think you're going to pick up 6.2 as fast as we need to. Have a great day, juniors. Good luck tomorrow, seniors. Pray the school is on time. Right? Yeah.
For that recommendation thing, are you going to say,
What?
I can give it to you, Chuck. I can do either one, Chuck. What do you want me to do?
I don't care